Okay, so here's the segment with the coils. These are over 200 turns. And I have a permanent magnet here. It's a nickel neodymium on a ball bearing within a cylindrical open clearance, hollow open clearance aluminum block. This is a low gauge aluminum. It's about 1 millimeter thick. I'm gonna continue with the design. I have a face, the enclosure that I'm gonna close. Okay, the motor exhibiting more than 200 turns. Each unit exhibits about more than 200 turns. So, in comparison, this is for electrodynamic self-repulsive levitation faceplate. This motor right here is a grinder, and this grinder has a commuter, as I stated, that exhibits about two coil terminals, and the coils are about 150 to 160 turns each terminal. So we're enumerated 160, and 160 will enumerate actually 320 turns. 320 turns to torque that. I think that sigma could be less as 135 turns to the commuter. The stack commuter is that emits against the armature in the central. That being a brush motor will still create the electromagnetic emission against the armature, causing it to receive both AC and DC current. Now, having the armature with an essential of a ball bearing bracket that can rotate in freedom like this. So this being a permanent magnet and the ball bearing being localized down here. Whereas if this being the commuter, but communicate with this and cause this to rotate. Now the torque of that is kind of too hard for a human being to grab onto. Nevertheless, to hold onto the force resistance so that the torque is not turning. If it was not connected to any gearbox, where the armature is connected to the gearbox, but the synchronous electrodynamics that is coming from the DC current, direct current into the phase wires, and into the phase wires into the brush that fluxes the density to the panels and causes the armature to turn, to rotate. And that will crank the gear shaft as far as the worming gear, and cause the armature to rotate. But if it was without that, it'd still be hard. It would still remain hard and stiff enough to not rotate. That torque speed is over a horsepower, a little bit over a horsepower, maybe 1.2 or 1.3 horsepower. When brand new, probably 1.5 horsepower for rotation. Now, 1 horsepower converted is 1 horsepower in electrical energy is 767 watts, and to convert 767 watts into pounds, that's 550 pounds force. Now, this gauge of this aluminum foil, which is 1 millimeter faceplate, it weighs a couple of ounces. However, in addition to coupled with it is coils that weigh more than that. Now the coils are enumerated together maybe 1.3 pounds, 1.3 pounds, and the 1.3 pounds, 1 pound and 3 ounces. We're enumerating this along, in addition, the nuts and bolts, we're enumerating probably 1.5 pounds. So about 2.5 pounds. I believe so. In addition to that, because my coils are 1.5 pounds by themselves. Now, by themselves together, they enumerated together, it's about 1.5 pounds. So right here is probably 1.2 pounds. And that's excluding the aluminum. Now, when the torque armature is locally near the magnetic emission, however, there's a distance between the armature, like with the grinder, there's a distance between the armature and between the commuter that's communicated with it. However, being synchronized and at the same time being brushed with another current carrying DC phase electromagnetic pulses. Now, as far as the electromagnetic pulse, when sending current, carrying current, to generate the power of current, where it's local to the surfaces, not as distance as millimeters or distance. However, coupled to the surfaces, where the torque forces is so much, 550 pounds of trying to grip it, the armature is going to rotate like that, and it's going to be hard and resistant. So the force to move it as an actuator is able to move this aluminum up to the gear. However, the aluminum repulses back and phase back, and sends the phase back to it, causing whether if it turns vertically like this, the copper will move away from the aluminum up into the gear. Even though the aluminum will try to fall backwards to move the opposite direction vertically. However, the copper will move away and move up in the ear. So if it touches the ground, it will fly up in the ear to try to escape from the aluminum, thus in the ear. And in addition to that, if it turns vertically, the aluminum would move forward. If it turns vertically or horizontally, it will move up, and if it turns vertically, it will move forward. Now, the possibility of moving backwards is depending on the phase angle of the wire. Where the right hand will what point is generating our charge for the electrical energy line. while a pull and push force, where the magnetization of the whole effect is in a different direction, forcing it to move backwards to where it repels away from the aluminum, however carrying the aluminum as its proportional weight against gravity, while carrying the inertial mass at the same time, dragging the aluminum along with it, coupled to the frame. So the torque forces, to sum this up, the torque forces that is needed, that shall generate the energies, is greater than the rotation freedom ball bearing bracket armature that has no friction or static, just the unstable items of the coil not to rotate, however having full freedom to rotate in an atmospherical environment at distance from the space of the commuter, even if it was a permanent magnet motor or a brush motor. However, this has a locking point that keeps it in place, whereas the torque force that is needed in order to send electrical energy is similar to the same. However, this is greater than that because the turns are greater. When the turns are more than, then it gives more of electrical energy and more of Ampere force. So the force that moves it is greater than 550 pounds, as that is about 550 pounds torque, which is 550 pounds, which is 1 horsepower, given in energy as 767 watts. However, these bearing more coil turns than those that's in that grinder, and the turns of the grinder may eliminate to 135. Maybe 135 appear. These two pairs eliminate together as 270 turns. So these are more than 200 turns per unit. I don't remember exactly how many turns, but they're more than 200. And they're in series and linear motion, so that it won't stick until the series move forward. Because of the electrical energy winding, will cause it to move forward. The aluminum move forward, while at the same time attributing the inertial drag force. So, my name is Jermaine Morton, and I'll get back to you on this design. I already showed you my breastplate, my chest plate of the Flymorton with the electrical winding energy as far as the coils. I'll get back to that to show you more on the design and how it will work. After I finish adding certain segments to this, I'll be back. My name is Jermaine Morton, to be continued. Goodbye.